DNS is one of the most critical components in every system, application, cloud, data center, and even in the internet. And today we are going to talk about CoreDNS, a DNS that installed and deployed in almost every Kubernetes cluster out there. We are going to talk about what is CoreDNS, how it works with Kubernetes, and also demo some capabilities with CoreDNS and Kubernetes together. Day number 10 of 30 days of CNCF projects. Let's go. What is CoreDNS? Let's take a look on the definition on the website because it's a really unique definition for what is CoreDNS. CoreDNS is different from other DNS servers such as All Excellent, by the way, Bind, Not, Power DNS, and Unbound. Technically a resolver, but still worth a mention because it's very flexible and almost all functionality is outsourced into plugins. What does it mean? So CoreDNS is a DNS service, as you may guess. The only thing that is very unique about it is that it's got a core of a DNS. The functionality of being DNS and doing resolution is there. But the main part of it is that you can extend it to do whatever you like using the plugins. It's heavily rely on the plugins, so you can customize, change it, and do it. Meaning that the core part of the DNS will not be changed, and the heavy lifting will be done on the plugin, and you will be able to craft your own core DNS based on the plugins, and you would not need to have like very heavy lifting DNS with plugins and capabilities that you don't really need there. So this is what's so unique about core DNS and the ability to plug it to Kubernetes and some other tools. This is what makes it so unique and so powerful. CoreDNS and Kubernetes comes together. So you don't have to use Kubernetes when you want to run CoreDNS, but it turns out that CoreDNS is the most popular DNS for Kubernetes. Why is that? Because the Kubernetes plugin is so well integrated, and the other part is that CoreDNS is lightweight and scalable, so you can use it in a very large cluster and do not afraid that it's going to break. What I want us to do next is take a look on the architecture. First of all, how things are connected, and then see how traffic in a packet can be sent through the network when we get the DNS resolution. So on the first layer, what we can see in here is the CoreDNS core. This is the part of CoreDNS that you get out of the box. We connect the Kubernetes plugin to it, and what it will do, it will connect to the Kubernetes API on the same cluster. So what we are going to focus on this video is internal resolution, what happens when we have east-west traffic like pod to service, etc. CoreDNS got some also capabilities for external resolution if a request comes from outside of the cluster to connect to different sources using plugins, but we are going to focus only on internal resolution today. And the Kubernetes plugin will auto-update from the Kubernetes API, meaning anytime a new pod spin up, CoreDNS will be able to resolve the IP of this pod based on the information resides on the Kubernetes API, and all the pods in the cluster will be able to send traffic and get IPN resolution from CoreDNS. Let's take it one step deeper and see how it looks in action when we have a pod that tries to send information to service, let's say service A. So on the left side, we got a pod, at the bottom we got service A, and what happens is that our pod needs to understand which IP is the relevant IP for service A. So it sends a request to CoreDNS. CoreDNS may have, but let's say it doesn't have the information. It will query the Kubernetes API, get the IP from the Kubernetes API, send it to the pod, and then the pod got an IP from CoreDNS using the Kubernetes plugin. And from that point, the request can be sent to service A using the network. And this is amazing because now we can alternate and switch CoreDNS and the plugin to Kubernetes, also add another plugins and extend that, making sure that first of all, east-west traffic within the cluster is scalable when it comes to DNS, but also we can extend that if we want to. Let's take an example when we want to connect two plugins. So one plugin will be the Kubernetes plugin as we know it, but on the other side, we can also connect our CoreDNS to Prometheus, and then metrics will be scraped and queried from Prometheus. This is very valuable because it allows you to connect not only Kubernetes, but also Prometheus, not only internal, but external ones, all in the same way. And then Prometheus will query the information from CoreDNS. So, and there are dozens of plugins. We are going to talk about them briefly later in this video, but this is the power of having a really powerful DNS, really good plugin, bake them together and get scalable DNS inside our clusters. There are two main groups of plugins, and you do need to understand which group do you choose when you want to add and extend a capability to your own core DNS. The first group is in-tree plugins. In-tree means they are in the tree, in the Git repository, meaning they are part of the project, they maintained as part of the core DNS project. It's very highly recommend to use those because when they upgrade CoreDNS, they also make sure that those plugins compatible with. Those ones are actually maintained by the project, and they are not like someone out there that actually maintain the plugins. They are trustworthy, they are tested, easy to plug in, and everything is much, much easier and safe when you want to use them. There are a lot of in-tree plugins, just go there and check them. The next group is out-tree plugins. Because CoreDNS is very extendable, you can create your own plugin or use some open source plugin. Here are three plugins that worth mentioning if you do want to use CoreDNS and you think what can be done with it. So the first one is Health. Health is a plugin that actually exposes an health endpoint that can be used for the readiness probe. Anytime you will probe the endpoint, you would get HTTP 200 OK if everything is fine with CoreDNS and nothing if not. It allows you to understand if CoreDNS is healthy or not, and based on that, build the readiness probe of Kubernetes. Another plugin is Load Balance, allow you to add round robin capabilities and load balancing capabilities into the CoreDNS, something that is not out of the box when you use CoreDNS in its core component. The last part is Loop. Loop detects loops in the configuration. So if you have problems and loops with the configuration of the DNS, meaning that when you send a request to it, it will go into endless loop and you would never get a response. Loop will help you to discover those and make sure CoreDNS doesn't have them. There are many plugins out there. It's worth go and check them. There are plugins to integrate with cloud provider, cloud DNS, whatever DNS services out there to create much more an advanced architecture of DNS within your own infrastructure and also clusters. So worth checking and understand what do you want to achieve. Obviously, it's always better to understand what do you want to achieve and then search the plugin that will make CoreDNS allow you to do it. So go to the website and explore more plugins on the website. For the demo today, what we are going to do is to manipulate CoreDNS that we got already in our cluster. We are going to remove the Prometheus plugin, we are going to add it, we are going to change the way it resolves some of our domains in the cluster. So for that, what do we need? We need a kind cluster. By the way, if you would go to Auto DevOps Tools, the repository for the series, you will find out all the instructions so you can use it. We do have kind cluster. And in the kind cluster, we do got pods in the kube system namespace. Maybe I will go with deployment. It will be easier to see that. And CoreDNS is already being deployed with kind. So we don't need to take care for anything. Kind is just out there. What is very important for me to show you is that if we will do describe config map for kube system, and then we will see the CoreDNS config map. Let me make it a little bit bigger. What we can see in here is the core file configuration for CoreDNS that we got errors, health, ready plugin installed, Kubernetes plugin installed with what should be resolved, like cluster local, the thing that we always know when we want to do anything in between pods and east-west traffic. Inside the cluster, pods insecure, TTL, Prometheus plugin, forward, the loop, and the load balance plugin that we talked. Everything is installed, and this is a very basic core DNS configuration file. What I'm going to do next is, first of all, I'm going to apply a service called utils. We can find it in here. It's a very basic deployment. It's got like a utils packed in it. So what we will do is that kubectl apply minus kubectl apply. And without typo, okay. So we deploy the utils. What the utils got is, if I'm going back in here, so the utils is a very basic container image that got some DNS tools in it. The tool I'm looking for is the dig tool. So if I'm going back to the README, I'm going to shell into that pod. Okay, let's wait for it to be up and running. It's content creating. When it will be running, I will be able to show you, but I'm going to use mainly dig. So dig is going to be the command. Dig is a command that allows you to do DNS queries and get the resolution from the DNS in the cluster. So let's wait for it to be ready. Container creating, it may take a while. What I also wanted to show you is that if I'm doing kubectl get deploy kube system, you would see that we have only 2 pods of CoreDNS. Why we got only 2 pods? So one thing is that if we do have a very small cluster, we don't need much of a scale. But obviously, if we got like 100 nodes cluster with 10,000 of pods, 2 pods will not be enough for the cluster. So we allow to scale the pod. So we can, first of all, do a few things. One, we can scale CoreDNS to have many pods, but those not always be valuable because we want pods to send requests to the closest CoreDNS in the cluster and reduce the number of ops. There is also variation to deploy CoreDNS as some kind of a daemon set that will allow each pod in the cluster to query the CoreDNS on the same node and reduce the east-west traffic for DNS resolution in the cluster. So in this example, kite example, 1 node over my laptop, I don't need more than that, but obviously CoreDNS can be scaled to do multiple things. So now that we have the utils up and running, we can connect to it. And now that we are in, we can try to understand what is the status. So if we are going dig to google.com, let's see the result. We can see that we got IP from server in very small amount of time. We can also dig for Kubernetes default cluster local. This is the Kubernetes API when we look inside the cluster. And we can see that we got a result immediately. By the way, it's an in-cluster IP. But if we will do dig for Kubernetes default SVC guide.test, it means that we will not get it. Why? Because it's not defined on the config map what is guide.test. So when we do dig, we do not get a result. If I will do... Okay, so the dig ended, but there is no result, which is not good for us. Cool. Okay, So maybe we want to add guy.test into the config map. So let's create a new config map for the CoreDNS. You can see the definition on the right side. Here is the same, but for the Kubernetes, we add also guy.test as a local domain name for the cluster. Everything here is the same. By the way, sorry, I removed also the Prometheus plugin. So we cannot find the Prometheus plugin, meaning our cluster or our CoreDNS will not be connected to Prometheus. So now let's deploy that. After we deployed, we can see that the DNS is configured. The main, sorry. Okay, we got a namespace. I thought I forgot the namespace. Okay, so we deploy the config map. Now everything is fine. We do need to do a restart rollout for CoreDNS, and we need to wait for the new pods to start. So we will do kube system. We can also grep core, get pods. And we can see there are both of them up and running for 20 seconds, meaning we are with the new version of them. And now, what is interesting is that we have added capability to the CoreDNS within the cluster, not by a plugin, but by configuring one of the plugin. So now we can resolve guy.test inside the cluster. So now we will take the same command from before, paste it at the bottom, and one we can see is that we got a resolution for it, for the Kubernetes default SVC in our own cluster. And this way we manipulated CoreDNS in our cluster using the CoreDNS config map in the kube system namespace. What we want to do next is to deploy Prometheus and see how the Prometheus plugin works. So let's deploy Prometheus on the cluster. It can take for it some time to run. It needs to deploy all the kube Prometheus stack with Grafana, Prometheus, all of them together. So we will wait for a while to see that we got it. By the way, right now it's not reporting because we removed the plugin, but you can see that on the new configuration that we are going to deploy next, the Prometheus plugin is there. Let's deploy it. And we will also need to do the rolling restart. Cool. And the next part is that we do want to connect to Grafana. You can see that now it's up and running. And now we can connect to it. Cool, so we got Grafana on the right side. By the way, if you do need the credentials to connect to it, you can always do that from here. So admin and prom operator. Those are the default credentials for any Grafana out there. And now we are looking for the dashboards. In the dashboards, we always got predefined dashboards and on the Prometheus installation. And now we got no data, but if we will wait 5 or 10 minutes, we will be able to see our data loads up into this environment. So let's wait for a few minutes and see how it looks. After we let it run for a few minutes, we can see that now we got our CoreDNS metrics in Prometheus. So when we removed it from the config map, CoreDNS did not expose metric to Prometheus. And when we added it, the plugin was triggered, and now Prometheus is able to scrape metrics from CoreDNS and show it in Grafana dashboards. And this is what's cool about CoreDNS, the ability to easily integrate, configure, and use plugins. And in this demo, we saw two main plugins, the Kubernetes one, and how we can use it to extend CoreDNS capabilities, and also to see how we can resolve some information using east-west traffic from one pod to whatever endpoint in the cluster, and also how we can integrate it with Prometheus and have metrics to our own CoreDNS. And the last thing for today is adding the CoreDNS sticker into the board. There you go. Thank you very much. Thanks you for watching. See you next time.